There. Time's flying. Three, two, one, go. And we're live. This is Retraice segment number 83, Re83 for Thursday, December 15th, 2022 at 10 p.m. Eastern, 7 p.m. Pacific. Retrace is about what's going on out there. The short answer to that is computer control. The long answer to that is natural, artificial, and strategic intelligence. Retrace is for outsiders. But we came to the, I thought I could do it in one breath. I should have taken a deeper breath. We came to the conclusion that the computer control game is, what about it? What conclusion did we come to? Is player oriented and outsiders are not players, blah, blah, blah. That's the long answer. In short form, what are we doing? We're in the December to Remember Math and Code event. You should know this by now. You haven't been paying attention if you don't. We're doing code right now. We're preparing for our deep dive into AIMA4e, January to June 2023. We're front-loading the difficulties so that we can kick some butt once the ball starts rolling, mixing metaphors all the way along. All right, so we're going to pick up where we left off yesterday. We are trying to, what are we trying to do? So we're working on what's the best first search, okay? But we're not actually doing, code. Start over. I'm juggling too many things, always. We are not doing AI code, or we're not learning the AI part. We're not focused on best first search. We're not talking about that algorithm. We're not talking about how is this AI or not AI? What kind of AI is this? We're not working on AI. We're working on math and code so that we can work comfortably and be relaxed when we work on AI. And that means, going after the things that we think are going to be difficult and seeing, testing our mettle to see how difficult they are and whether we can handle them. All right, you get it. Let's look at some things here. So this is the, yesterday we talked about passing a problem, whatever a problem means, passing it to the pseudocode at least, and we know this is going to end up being passed to Python implementation of the actual code. But the reason that we're working on this is because that's kind of that's a heavy lift. What does that mean? If you know a little bit about programming, you know what a function is and that you can pass it arguments. Here the argument is problem here, and then f, whatever f is here. Well, problem is going to be a well-defined object that we write in Python, and then the f here is the evaluation function. Oh, geez, I've already forgotten all the function names. Oh no, don't have it on the tip. It's the evaluation function. That's going to help order our frontier here of nodes in our search tree, in our search space, in our state space. And so these two things have to get into the function, and they have to exist before they get into it. So we talked yesterday about what it means to the difference between the English meaning of the word problem and the whatever we're talking about in AIMA4e meaning of the word problem, or the technical meaning, the encoded and formal and well-formed and well-defined meaning of the word problem. So we're dealing with the latter. We're not dealing with the squishy English version of that word, obviously, but it should stay firmly in mind that we have to turn that word problem into something that we can use code to work on. So here we have from yesterday's notes, this problem is going to have a state space, an initial state, a goal state or goal states, actions, a transition model, action cost function, and the state space, is that in the problem? I think it is. I mean, unless we specify the environment separately from the problem, and I think you can do that, but you might still have to represent the state space in the problem, or at least account for the state space in the problem. Anyway, what does all that mean? Okay, so we're going to do a little bit of coding now. Actually, I should say first, where does this come from? So if you go to the AIMA4e or the AIMA homepage and then click over to their GitHub, their official GitHub, I've copied this little chunk of code, the class problem. Okay, this is object-oriented programming. They have a class. They've defined a class of problem here that's got just sort of the basics that we're going to go through, that turns these fun English words and phrases and sentences into tractable programming in Python. And then what we're going to work on today is on our GitHub page. This is an adaptation of it. This is the latest version. I just pushed this before we went live, so this is pretty up to date. There's a lot commented out that we're not working on today, or we're not using today, but the stuff that's not commented as of Re83 is the stuff that's relevant to what we're doing. Okay, so now we're going to jump over to the terminal. Now, if you watched, what was it, 65, I don't know, the ones we did on the table-driven agent, we did some stuff in IPython. That's what we're going to do again today, but it's important to remember that you don't need to do this manually interactive approach to writing or developing the code or testing what you're doing. So we're going to do sort of a call and response back and forth with IPython as we did last time. But I'm also going to show you how you can just run the whole file and run the whole Python. It's a single Python document, source file, and get the same output. Okay, so that's the first thing to distinguish. Let's do that. Let's just do that quickly. Okay, so in the top here, we're going to just fetch our document. So we're in the Re83 folder that corresponds to the GitHub code that you'll be able to get yourself. Let's just open that and put it in read only so we don't accidentally do anything. Over down here, we're going to run we're in the same directory, but this is where we're going to run things. First, I'm going to source, what is it? What's my, no, don't do that. Oh no. Re, that's what I did. Source, Re, there we go. Bin and activate. All I'm doing here is activating a virtual environment for the Python modules and packages and everything that we install with pip. If you know anything about Python, this is not an environment. I'm already in an environment for my Python language, my C Python. This isn't that little Re83 over here. This thing right here, that tells me that I'm in an environment for my Python, my modules and packages and things that are in Python code that I'm going to use. We don't actually need that. Again, like what I started out doing was importing all this stuff that they do because they do it all in one file. So everything that they're going to implement in a single IPython notebook, Jupyter notebook, or in just a regular plain old source file, they import everything they need at the beginning. We don't need any of that for today, but it's still good practice to work in environments when you're dealing with Python. Okay, so now we're in the virtual environment. And up here, so if we just look at what's in our directory here, there's only one thing. What happens if we run this file? Okay, nothing. We don't get an error though, that's good. What that just did was take everything that's up here, okay, everything you're looking at up top here, we just fed that as an argument to the Python program or as a source file for Python to run, and it ran it, and the things that are not in orange, the things that are not commented out, actually got processed or executed. But there's no output, so you didn't see any output. If we just do blah, 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 oops, let's just do blah, 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 okay? And let's do the same thing. Now we get an error. Python doesn't know what I'm talking about when I run blah, blah, blah. Okay, let's fix that. Run it again. Okay, Python ran the program, did what we wanted, put our object, defined our class in memory, and then stopped because we didn't tell it to do anything interesting. Okay, so that's what's going on here. Hopefully that gives you a sense of, well, I mean, let's be a bit more explicit here. Let's say print something, wonderful. I don't think, yeah, it's got to be in quotes, right? So it's not good. So Python is deciding whether or not we are doing things correctly, and now we're doing them correctly. See how I did that? It needed to be in quotes. And anyway, all I'm trying to illustrate here is that the stuff that's in this file is what's getting run down here. Okay? So let's go to the top here. First, just some header information, where we're at in the repository, and then where a lot of this code or the substantive code came from. The AIMA repository. These are some of the commands that I use to get up and running in sort of a kosher way. You can use those if you want. You don't have to. These are all of the imports that they do in their source that are not necessary for today, but we will do these later. And some of the things like in matplotlib here, I had to do because of these imports, but we don't need it for today, so none of that is really relevant. Okay, so that's the end of all that. So let's just get rid of that, okay? And we're just focused on what we're doing today, which is the we're going to try and instantiate a problem, okay? So in object-oriented programming, what you're looking at is the definition of a class, and it's easier to see how object-oriented works. But if you, I keep copping out on this. Can I explain object-oriented? The whole point of it is to keep data and especially variables contained in a way that doesn't, so that you don't have all these side effects throughout your program, because when it becomes too big or complicated. So if you can contain the values of variables, especially, I think it's, and also, you can control what sort of changes can be made to that data, and protect it from being accidentally changed. So you've got, on the one hand, side effects from the data that you're working on affecting other parts of your program, and then you got on the other hand, other parts of your program accidentally affecting the data that you didn't think you were affecting. Object-oriented is one way of dealing with that general problem of side effects in your program, and it's just necessary when things become a certain level of complicated. And what it means in practice is you have a class of objects like oranges, and then you've got, and I'm getting this from Althoff. Althoff uses oranges. And then you've got an instantiation of that class, which is a particular orange, and you call that orange an object. So an instance and an object are mostly synonymous. It depends, in my opinion, based on what I've read, I think the words do mean different things, or they should be used differently, but they both refer to the same thing almost perfectly, almost identically. Almost, this is the key word. So what we say, the way we're going to use the words, we say that we're going to instantiate the class problem, and our object, P1 is what we're going to call our problem, is an instance of the class problem, or is an instantiation of the class problem. Okay? But you just have to get used to it. I can talk to you all day long, and it's not gonna sink in until you just play around with it. So let's play. All right. These are comments. Okay, they're just explaining how they structured and what they did. Oh, I gotta toggle trunk so it's nice and flat. This is not good form to have such a wide or such a long line of characters here, because I'm going all the way to the end of the earth over here. But it's easier to understand this section, the actual code, if the comments don't create a bunch of new lines. So that's what's going on there. All right. The first line is the initialize. This is sort of standard. What arguments does it take? It takes its name. So like when you define. Okay, let's stop talking. Right. I'm going to uncomment. No, I'm not going to uncomment. I'm going to actually do it. Okay. So let's first get this class into our IPython memory. Okay, and I did it again, didn't I? There we go. Okay, IPython. I also installed IPython inside the virtual environment because I got a little recommendation message for that too. So even if you have IPython, if you do a virtual environment, install IPython using pip inside the virtual environment to avoid problems. Okay, so we're in IPython now, our little interactive helper. I'm going to paste that in. It's huge. It doesn't fit in the screen. You can see this is what I'm about to put in there. And okay, no errors. So let's go back down. Okay. Now our class is in memory, thanks to our cut and paste into IPython. Now let's, no, I can't do that. Okay. Now we're going to do the only thing that we came here to do, which is we're going to instantiate that class with an object. We're going to create an instance of the class problem, and we're going to call it P1, and we're going to give it we're going to give the problem class a couple of arguments that we're going to play around with. Okay? Now, just before I do this, remember what we're doing. We want to write AI code that can solve problems. And we can't, the AI system at the level that we're working on it is not going to be, it's not going to know what we're talking about when we use the word problem, no matter how we use it or how carefully we write it in English or on any basis of English. We have to decide how we're going to structure problems so that they can be solved by programs. That's the essence of it. Okay. If we go back to yesterday's notes, this is our structure. Okay. So we start with, let's say we want to get from A to B, from A to B. We have to decide how are we going to make a computer solve this and not solve it ourselves? Well, they've written a pseudocode algorithm over here, but the most interesting part of this algorithm to me is the problem argument that is not here dealt with at all, but it's dealt with on prior pages. I think it's mostly page 65. And what we gather, or what we agree to on that page 65, is that a problem consists of a few different elements, and most of them are sets and some of them are functions. So a set of states, which is the state space, an initial state, which is a set of one, goal states, which is a set of one or more, actions, which are a set of actions that the agent can do, and then the function action, when it takes the argument of whatever state you're in, returns a finite set of actions that can be executed in that state. The transition model takes a current state, applies an action, and then returns the new state, S prime or state prime. The action cost function tells you whether the action you're taking is more or less expensive than an alternative action. So you take the current state, apply the action, and give it the current state, the action, and the new state it will be in, and the action cost function will return a numeric cost of getting from A to B, or S to S prime. It's not an evaluation function. It's not the F. If we look back at the other argument here, F, it's not the F. The action cost function is going to be actually built into our problem. We're going to see that in a second. And it's not the objective function that we talked about with gradients and partial derivatives. Okay, so we have to structure how we think about problems, and those are the 6 elements. They say 5, but I think the state space is part of the problem, and when they do the recap at the end of the chapter 3, I think it is. Okay, so that's what we're doing here. We're taking the idea of a problem and then saying, okay, here's exactly what we mean. We say it in English, as we did yesterday, and now we're going to say it in Python. Okay, where are we at here? So we're back down here at the bottom. I'm not there. Here we go. We're back down here at the bottom. We're going to send this, we're going to tell Python, okay, let's go through this one. Okay, we're going to tell Python to create an instance of the instance of the class problem, call it P1, okay? So create an instance of the class problem, call it P1. This is just an object in memory. Just think of it as data in memory with certain rules that are applied to it based on it being a member of this class. And we're going to give Python 3 arguments. Okay, the argument 1, argument 2, and then the keyword argument P1 test keyword. Okay, so let's just do that. Bang, nothing happens. Okay, so now what we've done is we've created in memory, and I think if I just type P1, it'll just return the memory address. Yeah, there's the memory address, 0 by, and then a hex number. It's hex, right? Yeah, it's hex. And so we can see that our problem, our instance of a problem, our object, which is an instance or an instantiated problem, is in memory at that location. Okay, and that's right there. We just instantiated a class. We just instantiated. Do you say you instantiated an object, or you instantiated the class? The object is an instantiation of a class. What did I call this segment? A problem instantiate. Yeah, I just want to make sure I said it right. And because it's, anyway. Okay, so now it's in memory. So it's a thing that we can interact with now. It's sort of part of the current state of the computer. Okay. What do we want to do to interact with it? Well, let's just print it. Okay. Look at that. It's already there. No, not result. let's just print what comes back. Okay, so what this is telling us is that the object P1 is an instantiation of the class problem, and it has two attributes. So that's kind of a new thing we haven't talked about. I'm not trying to teach you object-oriented, but you have to know what you have to have some sense of what this stuff means, or it's just gonna be gobbledygook. Attributes attributes are things that are part of an object, an instantiated class called which is what an object is, and they are one of two essential aspects of objects. And I don't think there's a third one, but there might be others, but these are the main ones. Attributes and methods. Attributes are like variables inside the object, variables that are only defined inside the object. If you try and interact with or call those variables or print those variables or change those variables outside without going through the object, without calling the object first, you'll get an error. And then similarly, methods are like functions inside the object. So you got variables and functions in non-object oriented programming, print my name, and I set my name equal to Jeff, and then I say print my name. So Jeff is a variable. My name is a variable. Jeff is the value of the variable. Print is the function, and then you give it the argument my name, which is the variable, and you got function taking variable and producing output, which is the value of the variable, a string. In an object, you can do all the same things, but you can only do it by going through the object, using the object in your call. You have to call the object at the command line or in your program. And you don't call them variables and functions, you call them attributes and methods, but they're the same thing. I mean, I don't know of a difference. I'm still, I'm not like, I don't have a lot of experience with this, but I've been familiar with object-oriented for a long time, so I get the gist of it. The hard thing about what we're doing is merging object-oriented with problem definitions, or the definition of a problem and the structure of a problem that comes from the AI. So on the one hand, object-oriented, just dealing with oranges and attribute, using the class orange and then a particular orange, and then it's this big and weighs this much. That stuff's easy. It's when you have to hold the object-oriented in mind and also the structure of a problem that things get a little bit confusing, and that's what we're going to get into here. Okay, so we see here that P1 is of type problem. It's an object of type problem, or the class problem, and then it has two attributes, 1 and 2. And those attributes are, we'll come up here now. Whoops. Not that. There we go. And those attributes are the arguments that we gave when we initialized our object. And first you give it a name, so we called it P1. So that's always the first argument that you give to when you initialize or instantiate an object from a class. But the second argument we gave was the number 1, and that was here it tells us that was our initial state, and the first argument, because we don't actually write in our argument space the name. So our first argument, like if we go back down here, here. So our first argument is 1, second argument is 2. Up here that corresponds to 1, 2, okay? And then we did keyword argument P1 test, okay? That's what we did. Whoops. That's what we did. And so that's why when we print, that's part of why when we print the object. Now, why can you print an object? Well, you can't print an object. It's data in memory. It's you could print it in different. You could print different representations of it, but it's really voltages inside your computer. But what you can do is use, if your class has defined a method for printing it, then you can use that to get a string representation of your object. And that's what happens down here. That's what these 3 lines are. Okay, so this is a method, a special method. These I should say, anytime you see these things that, whoops, I gotta, okay, there we go, read only. Oh no. No, we don't want to do that. Let's do undo until the universe. Okay, and now we read only. Geez. Still? Okay, now let's do read only. When you see these double underlines, those are special reserved methods reserved by the language in Python. But the ones that we, or that the AIMA people put in there, are these normal looking functions that we call methods when they're inside of a class, and then they become part of an object. So down here we got the special method of string, and it takes the it takes the name of the object that you've instantiated, and it returns a string between this pink part, and then it formats the string thusly. So first it gives you the type of the object, and it returns the special method name. That's what we're getting when we get this part, this word problem. Okay, that's what corresponds to problem. And then it's the next thing it's going to format and place in the in what it returns in the string that it returns is the initial state that we defined down here. That's the 1. Okay, and then up here we've got the 2 that we gave it. And so when we say print P1, what we're doing is we're using the print function and giving it the argument of our object, and our object has a special method that it uses when the print function calls it, and it's this string method. Okay, and it's these 3 lines. That's how that's happening. Okay, now, okay, so we've talked a little bit about. Oh, and the other thing is this line here, this self.dict .update. It takes the arguments that we gave it, so our initial state and our goal state, which were 1 and 2, and our keyword arguments, and adds them to the dictionary of the object, which is another special method. So I don't know what would happen if we, I don't know how to get to that. Hang on. Oh, let's see. So let's see if this. I'm very sort of, I have not done a lot of object oriented. I've done a ton of procedural. Yeah, there we go. There's our dictionary. Okay, look at the braces. So what we're doing there is I'm telling IPython, would you please print the dictionary of this object, my object P1? And it says, sure. Your initial value is 1, your initial state is 1, your goal state is 2, and your keyword argument is P1 test keyword. Okay, that's what all that is. Whoops. And, oh, geez, seeing all my secrets. All right, so that's what's going on in these first 2 lines. All right, so just to review, up here, we've defined a class, and the first 2 lines that aren't commented initialize it, and then also add our arguments to the special dictionary method that we can use to find out information about an instantiated problem, an object that's an instantiation of problem. Now, this section here is what we really care about, and we haven't done most of the work that's going to make it useful, but it corresponds to these 5. Okay, so what do we have? Action, results, is goal, action cost, and then we're going to ignore H for now. Okay, H is for informed search. We're not doing informed search in our current situation. Okay, so actions, result, is goal, and action cost. Let's go to our English model. So you can see here action on state. Okay, wait, did it say, so the action, that's the only one. Yeah, okay. Returns a finite set. I might have, was that supposed to be actions? Maybe I was supposed to type an S on the end of that. I think that's right though. I don't know. Anyway, so the action function, when given the argument of the state, the current state that the agent is in, sorry, wait, not the agent. The agent, the current state that the agent is in, that corresponds to this first line that we're looking at here, okay? So this is a function inside, so we call it a method because it's a function inside of a class, so it only applies to an instantiation of that class, an object. It does not apply outside of that object. And it takes the argument of the name of itself, the name of the object, in our case it's P1, and then it takes a value of state. Now, how do we demonstrate this? So what we're going to do, let's see, how did I do this? Yeah, just, okay. P1.action, oh geez, I don't like it's autocomplete. Okay, so I'm typing P1, and I want to use the method actions that's part of P1, or that's part of the object P1, and I'm going to give that method the argument 2. It already knows what I'm going to do because I've done it. And what I'm doing down here then is basically using this function. We have to call it a method, but it's it's just like a function. I'm using this this method to try and do something. I want to get a list of actions that are available to me in state 2. If I'm in state 2, can I please, geez, didn't I? Man, I thought oh, come on, man. I'm supposed to be read only. All right, geez, this is gonna cause us all kinds of headaches. So let's do that, okay? So let's use the actions method on our object P1 and give it the argument 2 to see what actions we can get. Uh-oh, not implemented. Geez, I keep doing that. Not implemented. This part corresponds to, you guessed it, this part, okay? This just means that we haven't done anything. We haven't defined this method. It doesn't do anything. We've said that it takes an argument, state. We've said that it's within the class, it's part of the class problem, but we haven't given any more lines of code below it that would tell the machine what to do with that argument. Okay, so we haven't implemented the actions, and really it's something that we could. I think that we're supposed to implement in a subclass of the class problem. But anyway, don't worry about that right now. Subclasses will just confuse you and me right now. Okay, so we get a not implemented error. Let's do the same thing and look at results. Can we? Whoops. Results. No, what did I do? Result, right? Yeah, it's the, okay. I think I mixed up some of the S of the plurals there. I need another argument for result. So first I'm going to give it the state, and then I'm going to give it an action. What's the action going to be? Jump. Let's just make it jump. This is just going to throw an error. I'm just trying to see, not implemented. Okay, so not implemented. And we see it here. If I can just, there we go. Okay, what about is goal? Whoops. Okay. Is goal, yes. And let's give it an argument. How many does it need? It just needs 1. Is 2 the goal state? Can you tell me, please? True. 2 is the goal state. Wow. Why? Because when we first instantiated this object, or we instantiated the class by creating this object, look, our second argument was 2. Okay, so I just asked the computer to check whether to use the isGoal method that's part of P1 to check if the goal state is 2, and it came back and it said it is. That's exactly what it's supposed to do. Is it going to say that about 1 as well? Is it stupid? No, it knows that it's not 1, it's 2. Okay, so that's isGoal. Okay. Happily that worked. I'd actually never quite run that little experiment. Action cost, we can pretty much give it any argument we want, because we don't have, it wants 3 arguments. So let's say we're in state 1 and we want to take action jump and we want to get to state high. Okay? Oh yeah, I know, I got to put them in quotes. Come on. Oh, don't do this to me. You don't do that? Oh, come on. That's not cool. That's not fun. That's not fun. I should just be able to hit quote and it quotes it both. Oh man, I'm not happy with IPython. Honestly, no, it's fine. Okay, so what's the action cost of being in state 1, jumping and ending up at state high? The action cost is 1. Why? Because all action costs are 1 right now. We haven't defined different costs for different actions, so that's why we're getting that. Okay. Let's just see what the heuristic is. Okay, we want to do informed search. We want to, it takes a node. Let's give it a node. Let's see what, let's just make a node, huh? There's a node. That looks like a node. Okay, so it returns, it's guidance, the heuristic that returns only one thing, and the thing is 0, is guiding us by telling us, hey, when you're at that JKF LSD, the thing you should do next, or the whatever, the heuristic number, the numerical heuristic is 0 because it's always 0 because we haven't defined anything interesting over here, okay? So recap, okay, this is just the class definition line, okay? These are all the suites, they call them suites inside here. I think they're called suites even if they're one line, but these could be 2 lines. We could do them differently. Each of these function definitions, these method definitions. Okay, so we've looked at how all these correspond to, what do they correspond to? They correspond to, actions corresponds to the actions, which is the 4th item down there. Result corresponds to the transition model. Is goal corresponds to the goal state item. And action cost corresponds to the action cost function, and then we haven't talked about H, the heuristic, the informed search, because we're not doing that yet, and we're doing one thing at a time, okay? So far so good. That's the hard part. Now, I've put more verbose, or less verbose, let's be honest, explanations here in the comments, and they go all the way to 11 over here, because I just wanted to keep all this stuff in a nice, tidy little one line after another thing, so you can check those out if you want to on our GitHub. And we talked already about the special method, string method, so that we can just print some information. Oh, by the way, okay, so what if we wanted to play funny business? I gotta get out of read only here. Okay. Now I'm going to just do some funny business. Oh, damn it, I knew it. My key binding for commenting and uncommenting is not good. I keep screwing it up. That's how I know it's not good. There, well, that worked. Okay. So what have I done here? Don't do that. Come on, you're fine. Don't. Oh, is it because of the white space? No, it's not the white space. You're fine. It is the white space. Okay, my fault. What I've done here is I've kept the first line of this suite, okay, the first line that starts the definition of the special method string, but I've changed what it returns, okay? So I've added one more variable. It's not a variable, but it's acting like a variable. This is like the exclamation point means it's like the shell is doing it, I think, in Python. I'm not going to get into that. Okay, and then I added one more thing down here, self.keyword, because I want, when we print our object as a string, I want to know, before we were doing it, okay, well, right now, so IPython still has come on, I can't delete that. Are you kidding me? Are you kidding me? I have to hit the delete button. All right, IPython, we have to talk. This is not cool. So if we print the current version of P1, then we're not going to enjoy that keyword. Look, I gave it a keyword. Not there. Where was it? There. When I instantiated this class problem as P1, I gave it a keyword argument, a P1 test keyword. Okay, but when I print P1 as a string, I got nothing. I got the initial state and the goal state. I got no keyword. Why? Well, you can see where this is going. So now I'm going to put this definition of class in IPython. Oh my gosh, I am so not slick. I'm kind of slick. All right, let's put that in there. Bang, bang. And just, you can't see it, but this is what we just did, right? Okay. And be slick. Show them how you're slick. All right. And now we need to instantiate our class again. Oh man, I have to do that too. I forgot I have to go through the whole crap list. Okay. Okay, so we're going to do our problem again. We're going to basically replace the object or create a new object. And I think this clobbers the old object. It should clobber it. We'll know pretty soon here. Actually, no, we don't need to. No, yeah, we do. Yeah, we do. We have to do this. Okay, so we just did the same thing. We just instantiated class again. Oh, this is so stupid. I gotta just, I don't want unexpected things here. So let's just do this again. Okay, send it in. And this stupidness. No, there. Okay, now we got a fresh start. We got a new definition of problem that has those new lines in it, right? This is like newness. These two things are new in the thing we just sent over to IPython. We just define the same object or define an object in exactly the same way. Actually, let's see where it's at in memory. That's not the same address, right? So that's good. That means that we've really got a new object. Okay, so print P1. Look at that. This, oops, oh geez. This is all of my things. I've been doing that a lot lately, like making that particular tmux mistake. It's like my pinky just is not landing where I want it to. P1 test keyword is now part of what gets returned by the string special method, because we put it in there, okay? So we put it in here, you gotta put it in there, and then you gotta put it in over here or something, and I still don't know really how to, how to explain that exclamation point thing, but I know what it's doing. You've got 3 selves with the attributes, the initial, and then the goal, and then the keyword, and they correspond to the R and the R and the R, okay? That's what we did there. And I think that should do, I mean, we can define a new problem here, like, don't worry, I'll get better at this with time. And then let's print the P2 and close it. See, I'm used to things that do that automatically. See, we've got a different keyword now and different different initial and goal states. Initial state is A, goal state is B, keyword argument is testing keyword with a capital K. And, oh, another thing, if we see something like this, so when we print the object, the first thing that comes back is this word problem. Okay, why does it say problem? Well, it seems like it would make sense, but why exactly does it say problem? It's because of this thing, okay? This little type of the object itself is our stand-in for the name of our object. So our object name in this case is P2. So type of P2, use the special method name to return that type, and it returns, you guessed it, it returns its type of object. What type of object is it? It's a problem, okay? So type, and, whoops. Come on, I'm trying to make it easier and I'm making it harder. You know all about that, don't you? Everybody does. Okay, so type of the object, take the type, use the type function, pass it the object, and then find the name of the thing. So we can do that manually if we just use the type function, P2, and we do the little namey thing. What type is it? Its type is problem, okay? Last thing, stay with me. I'm going to just do one last thing so that you just know that this stuff doesn't have to be so IPython-y. We have, what's the best way to do this? Let's do this, and this, and this, and this, okay? And that was not elegant. Let's do that again. Let's do this, and there we go. Okay, key bindings that work. And a typer who can remember them. Let's get out of IPython. Okay, and where are we again? We're in our directory, Re83, best first search part 2. We're in our environment. Okay, this is our little venv environment, and what we're going to do is just call the Python program and feed it our best first search. Let's make sure this is saved. Yep. And bang. See? What just happened is first Python read in all these lines and defined a class problem, a class of object called problem. Then it read in this line and instantiated that class in the object P1 with the arguments that we gave it there. And then it printed the string method of that object, and the output was this here. Okay, so we told it to print it, so it printed the type, and then it printed the first argument, which is the initial state, and then the goal state, and then the keyword argument. And then we did the same thing right down here. We instantiated the class as an object, and then we printed the type and some other string stuff as we've been doing. Okay, that's it. 44 minutes. Sorry, but I had fun. I hope you did. That's object-oriented programming. That's an instantiation of a problem, a really I mean, we didn't really give it a problem, but from a technical point of view, we did the hard part, which is we need to implement problems, well-formed, well-stated, or well-defined problems that we get from the real world via our well-defined method, which is, again, it's this stuff. Whoops, not that stuff. This stuff here, okay? We want to implement our squishy problems by running them through this clear thinking set of list of things, and then next, turning them into implemented computer code so that we can start actually writing other code that will work on them and solve them as problems, as well-structured, well-defined problems. Okay? All the notes will be at, where will they be at? Let's show you where they'll be at. It's retrace.com. I just started this new profile, so I don't know what just auto-completed, but I swear it's just suggestions. It's not me. I saw a little cartoon character, and I'm not into cartoons, man. I'm a big boy. All right, so this is our website. You've got the podcast. You got the latest videos. The one we're on now. Ooh, meta. You want to do some meta? I'll do some meta. As well structured. Look at that. Well-defined problems. Pretty cool. Okay. All the notes will be at. All right. You can go to notes, you can go to our GitHub, you can go to the blog. Blog is kind of stale, I'll be honest. I'm hoping to use it for things in the future. It's got some cool stuff on it, but it's not like you don't check it every day. I mean, you can, but links.retrace.com, I really like this. It's like you want to get to some stuff. This is going to keep growing over time, but I find it handy. And then our social media, et cetera, et cetera. Enough. Okay, you get it, the website. But anyway, all right. I don't have to say retrace.com. You just saw it. Same time tomorrow. Signing off.